Hello. Dear students, today I'm going to let you know how to work with QualNet simulator. So this is the icon where you are seeing it's a QualNet icon version 8.2. We have a paid license for this tool. So it stands for Quality Networks. So I'm going to launch this now. So once you open this QualNet tool editor, you will see a number of options here. So the architect window is highlighted here. So using this architect window, we can build scenarios. What do you mean by scenario? Each scenario will have a network, whatever we configure. So using this left panel, we have a number of devices which we can use, and UMTS devices, network components, and type of links, and applications, and dynamic applications, and single host applications, and other components like creating weather, mobility node, etc. So these are the tool set available for us to construct any network. So as per our first experiment, we are going to have a point-to-point network with the 3 nodes, and we will run an application, and we have to configure the properties of nodes and communication link. So under the devices panel, this is a default device which we can pick up to configure it as any default device. Default device means it can be an ordinary PC with some computation power. And before going to pick these tool sets, first we will look at this scenario properties. If you click on the scenario properties, you will get a panel here. In that there are general settings. It will reflect the name of the experiment and simulation time. So we have allowed 30 seconds of simulation time to run the scenario whatever we build here. And the seed time and scenario background image. If you want, you can put any background image for your scenario. And the second panel shows the terrain. Terrain means the layout structure whatever we have. So that is 1500 by 1500 grid lines we have in this architect window. This is 1500 by 1500. So 0 to 1500 here and 0 to 1500 here. So with this 1500 by 1500 layout, we are going to build a scenario. It reflects the coverage of geographical area for the network whatever we configure. And here in the general scenario properties, you can change the simulation time if you want. So this is about simulation, scenario properties. So now I'll click on this device so that my mouse pointer will be highlighted with the device type whatever I have chosen. So if you just click on the screen, it will make a placement of a device. So 1, 2, 3. I have placed 3 nodes here, and go back and click on this arrow to deselect the device. And I have 3 default devices, and now I will connect them by using this link. So this is duplex link. So once I click on link, again my link is highlighted. So from 1 to 2, I just click on the device and hold on the mouse and drag the pointer and leave this pointer at 2 so that it will build a connection between 1 and 2. Similarly 2 and 3 and 3 and 1. So once I start linking from 1 to 2, so 1 will act as a client and 2 will act as a server for this communication link. So now I'll set the properties for these nodes. If you right click on the node and go to properties, you can see the general properties like name, icon, etc. And if you click on a node configuration, under the network layer, you will have a schedulers and queues. So under schedulers and queues, you can change the queue size, and you can even change the number of queues available. So these 2 parameters you can configure. As of now, I'll just leave the default values. And if you click on a communication link and go to properties, you can set the properties for communication link. Under the general section, you have bandwidth. You can change the bandwidth, and you have a link drop probability. Link drop probability can vary from 0.1 to 1. So if it is 0.1, so the 10% of packets can be dropped to, 10% of packets are allowed to drop. So you can change this link drop probability and see the number of packets sent and received as well. So these two are the properties you can set for a communication link. So now I'll pick up an application from application section, not from dynamic. Okay, from application section I'm going to pick telnet. I'll run from 1 to 2 and I'll run FTP from 2 to 3. So now to run this, before running this simulation, we just have to save this experiment 1. So this creates a .config file under a scenario folders. Under user scenario folders, it will create a file. So now our scenario is saved. So once you save the scenario, to run you have to click on this icon, run simulation. So once this play button is highlighted, your scenario has been built. So once it is highlighted, you can click on that to play the simulation. So you can see the movements of packets here, right? So you can increase or decrease the simulation time as well. So once the run is complete, you should not click on any other button. You just have to click on this statistics window. So once this simulation is over and still it's in this architect mode, you can navigate to analyze statistics mode. So once you click on analyze statistics mode, you could see the FTP server, FTP client, telnet server, telnet client, and it has used by default Bellman-Ford algorithm to transfer the packets to all other neighbors, right? So now we can analyze some of the parameters. So once you click on the telnet server, so here we will see total bytes sent. So once you click on total bytes sent, since it is telnet server, the node 2 has taken as telnet server. If you just drag your mouse pointer on the graph, it will show the details of node and metric value and total metric value. So the metric value reflects how many number of packets are sent in terms of bytes. So it is 2771. So here in the client, how many bytes are received we will see. So that is also 2771. So all the packets sent were received at the client, right? And now how to analyze the throughput. So throughput unit is bits per second as shown here. So once you drag your mouse pointer there, it is showing 17. So how come you arrived at a 17? So here total bytes sent are 2771, right? So 2771 bytes you have to convert into bits because throughput is in bits per second, right? So this 2771 you convert it into bits. 2771 into 8 will give you bits divided by number of seconds the simulation is run. So how many seconds the simulation has run, you can analyze here. First packet is sent at the metric value 1.0. So after 1.0 second the simulation has started, and last packet sent at 29.7. So 29.7 minus 1.0, you would get 28 point something or 27 point something as a number of seconds the simulation is run. So now total number of packets sent, total number of bytes sent, that is 2771 into 8 will give you the bits divided by 27 point something simulation seconds. So that will give you a throughput value, that is 17. So this is how you can analyze the throughput and number of packets sent and received at the server and client both. So similarly, you can also analyze total unicast data sent in terms of byte for FTP server, that is 2903, and also for FTP client you can check total unicast bytes received, that is also 2903. So it is one and the same. So if you vary the link drop probability in the properties of communication link, you can get to know the changes in the experiment. So to go back to architect window, you can just click on this, and to come back to the architect window to build another scenario, you can click on this window, switch to design mode. So now you switch it to design mode. After saving this, again you can go to again you can create another scenario, so you can go and open a new file. That's all. So this completes the first experiment. Yeah, hello everyone. So now we will start with the second experiment. So second experiment is set up an IEEE 802.3 network with hub, switch, hierarchy of switch. Apply the FTP telnet applications between nodes, vary the number of nodes, vary the bandwidth, queue size, and observe the packet drop probability. So now we are going to construct a small network with a hub. So hub is located under the network components, right? So I'll pick up the hub and place it here, and then I'll take default devices. I'll place 4 devices. As you know, hub will create a single broadcast domain, so all these 4 nodes will communicate via hub, right? So hub is a which layer device? It's a MAC layer device, right? So now I'll take a duplex link to connect all these nodes from hub to all other nodes. So now if you look at the properties of hub, if you check the MAC protocol, it is 802.3, right? So it is already set by default. And if you look at the properties of nodes under the interfaces section, under interface 0, if you look at MAC layer, so the MAC layer protocol will be 802.3. So once you connect the link, by default all the devices will be set to the MAC protocol 802.3. So now I will pick up the application FTP and I'll run FTP between node 1 and 3, right? So if you want, you can set the communication link properties like packet drop probability, queue length, etc. for node and communication link. So I'm not setting any properties as of now. We will run the application with all the default values set. So once it is run successfully, you can vary the different parameters and run the simulation again and note on the changes in the parameter values, right? So now I'm going to save this experiment. XP2. So now I'll run the simulation. So now play button is highlighted. Please observe the packet exchange which will happen via these nodes via the hub, right? So just look at it. Yeah. So all the nodes are transferring the packet. So the packet transfer happened via the hub, right? So go to the statistics window. As usual, you see the parameters of this FTP server and client. So we can analyze the total bytes sent 2903. And here total unicast data received in bytes, that is also 2903. We didn't vary any other parameters, and you can look at other parameters as well. This shows the values. That is 1.2 something. That is a unicast fragment sent. So that is a fragment, right? So if you want to know the data sent in terms of bytes, it is here. In terms of messages, it is here. So it is showing 100 as total number of messages received. So if you divide these messages sent 2903 by 100, you will get the size of one message in terms of byte, right? So you can analyze other parameters as well. Messages sent and messages, first message sent, at what time it is sent. It is sent at the 2.9 second. Right? So you can analyze all other parameters, and it has used Bellman-Ford algorithm by default for connection oriented networks, right? So now we'll go back to the architect window, and now we'll start with our third experiment. Dear students, we will start with the second part of second experiment. So we finished with the hub network, and now we'll start with a hierarchy of switch network. So instead of showing only one switch with the nodes, I'll show how to demonstrate multiple switches. I mean hierarchy of switch with the nodes, how they'll communicate, right? So now the switch icon is located under devices, right? So I'm going to pick 3 switches. So one switch at the first level and 2 switches at the second level, right? And I'm going to pick 4 devices. 2 devices I'll connect to 2, and other 2 devices I'll connect to switch 3, right? So I'm going to pick a duplex link. Let me connect these switches as per the hierarchy. We'll allow all these 3 switches to communicate, and switch 2 will allow the communication between 4 and 5, and switch 3 will allow the communication between 6 and 7, right? So once you are done with these connections, so now we have to set the properties to the communication link. Go to the properties. Under general section, the link type will be wired, and MAC protocol you have to set it to 802.3 for all the communication links, right? So we will quickly do this. There is another way to set properties for all the nodes or all the links. So here you can go to the table view, and you can go to the interfaces, and you can select all the interfaces if you want, and you can set the properties if you are setting the same property for all the interfaces. And if you are setting the same property for all the nodes, you can select all the nodes, and you can set the property for all the nodes if it gets highlighted, right? And you could analyze all the interfaces between different nodes existing and network, okay? And also the groups, if the groups are present. And if you go to the network, you will get to know the paired devices to communicate via all the links. So we have a 7 links here between these nodes, right? So now we have to set the property for all the links, right? So the MAC protocol should be 802.3 because we are allowing communication to happen between nodes via switches. So now all the links are set with the MAC protocol 802.3. Let us check it for the devices. So if you look at the device property under interfaces, under MAC layer, it will be set, right? So once you change the communication link properties, the default property for the node will be changed to 802.3 under the MAC layer, right? So now we are set with the MAC layer property for all the communication links and as well as nodes. So now if we run any application, we could see the packet transfer happening. So now I'm going to pick up FTP and put between node 4 and 6, and I'm going to pick telnet application, and we will run between system 5 and 7, right? So just to allow a proper view, I'm just trying to drag this devices. So this is between these two, and this is between these two, right? Fine. So now we will save this experiment. So this is switch hierarchy, and now we will run the experiment. So once you click on run, so you may not notice the packet transfer happening because we are running a simulation for only 30 seconds. So you go back, click on the scenario properties, and you can set the simulation time as 60 seconds so that we could see the packet movements, right? So now I'll save once again. I'll run the scenario. Instead of I'm going to click on the play button. You could see the packet movement, right? So if you want to observe it carefully, apart from just clicking on a play button, we can run the step mode here, right? So if we run the step mode, it will show the step-by-step progress, right? So now it will show the packet transfer, see? Yeah. So now we will go to the statistics window. So under the statistics, we have run FTP and also Telnet. We have got a FTP server and client. So you could analyze how many fragments sent, at what time first packet sent and received. So all the properties, as you already know, and also end-to-end delay in seconds. So all the properties and its metric values you can see. And the message is sent in terms of bytes, 2705. And here messages received in terms of bytes, again same thing, right? We didn't vary any other property, so all the messages sent were received by FTP client. And if you go to Telnet, so the server has sent how many bytes? 1608, and client has received the same number of bytes, and again client has sent 39 bytes and server has received 39 bytes, right? So you can analyze the throughput and calculate accordingly, as I explained in the first experiment, right? So we have got metric value 12 here for throughput. Fine. So this completes the second experiment with a hierarchy of switches.